What we're going to do here is make some acetylene gas by reacting it with calcium carbide. You notice that calcium carbide just looks like ordinary old rocks, but when it goes into water, there's a double displacement reaction that occurs, and it produces acetylene gas. So what I want to do is I want to handle these with my forceps rather than my hands because I've got water on my hands. Now the way we can collect this gas is by displacing water, because this does not dissolve in water, and since matter can't occupy the same spot at the same time, if I have gas that is going to be in here, then the water is going to be kicked out. Now the way I set this up is I fill a test tube up with water and I invert it in a beaker of water. Then what I'm going to do is I'm going to study the idea of a limiting reactant. So in the first case, I'm going to completely fill up a test tube with acetylene gas. So here comes the acetylene gas. I'm placing it over the test tube, and we're kicking out the water. Now, right now I'm just going to put a tiny bit of acetylene in this one. I'm going to fill this one with a little bit more acetylene, and I'm going to completely fill the last one. I'm going to speed this reaction up just a little. Put a second one in there and get this to react a little bit faster. Okay, so here comes the acetylene filling up this one test tube completely. And I know that it's filled it up when it bubbles out. And now I'm going to half fill this one with acetylene. All right. Now, because I don't want to smell this acetylene anymore, I'm going to take out whatever I can and get it to quit reacting. So I'm going to dry that off with, and here is some calcium carbide, if I can see that. Okay. All I'm going to do is just dry that off, get it to quit reacting, and we can save that for another lab activity. Okay. Now let's look at what a situation is. Here I've got one that is completely filled with acetylene. Here's one that's half filled, and here's one that only has a tiny bit. Now when I go and take this out, I have to keep the test tube upside down in order to keep the acetylene in the test tube, because it's less dense than air. Now and I'm going to go and ignite this. Now acetylene will burn, but right now, the only place where the oxygen can reach the acetylene is right at this lip. So when I ignite this thing, you can see that the acetylene is only burning where it can reach oxygen. And so right now, oxygen is a limiting reactant. I'm just shaking the acetylene out, and you can see there's all this soot that is present. Now, if you were to burn acetylene completely, because it's a hydrocarbon, we should have gotten carbon dioxide and water. But this acetylene wasn't burning completely. It was limited by the fact that there wasn't enough oxygen to go around, so we got good old ordinary carbon forming. Now look what happens if I have it half filled. Now when I go and remove this test tube, what's going to replace it will be air. And air has some oxygen in it. So I'm going to place my thumb over this, and I'm going to mix up the oxygen with the acetylene. Now here I've got a little bit more oxygen and a little bit less acetylene. When I go and ignite this, do you see how it now puts the soot going all the way down the test tube? I still have excess acetylene and not enough oxygen to go around, because if I had burned all of that, I would have ended up with just carbon dioxide and water, not that. But do you notice how it burned all the way down the test tube? burned all the way down the test tube because I had put oxygen in the entire test tube, whereas in this test tube, the oxygen was always on the outside. Now let's look at this last instance. Here I have almost, well, very little acetylene. When I remove this and now air fills up the remainder, and I put my thumb over this and I mix the oxygen with the acetylene and bring it over here, we get almost complete combustion. Now if I hold this up against here, you can see it's still a little sooty, isn't it? So what I want to try to do is I want to try to get complete combustion. If I get complete combustion, that will be a completely clean test tube. So I've got one more test tube here. Fill it with water. Invert it in here. So I need to have a little bit less acetylene and a little bit more oxygen. So here comes my acetylene that I'm collecting. Okay, that's probably good enough. I don't know if I can reach that. I'm not going to bother with that. Okay, now I'm going to lift this out. Now I have a whole lot of oxygen, very little acetylene. Mix this up really well. It might seem weird to look like we're trying to mix gases, but keep in mind that just because it's not a liquid doesn't mean that it can't, that it doesn't still need mixing. So I'm going to stir this up, get it real close to here, and now I definitely have excess acetylene. I'm sorry. Now I have definitely excess oxygen, and all of the acetylene was gone. And notice how the test tube doesn't even need to be washed.